Hello everyone, welcome back in another video. I am Vaibhav. Today date is 1st of September 2022 and our today's video topic is internal implementation of TreeMap. So in our previous videos we are discussing about linked map and linked hash map. So those are implemented from a map interface. And then another now our today's topic is again depends on map, but that is our tree map. That tree map it's implement from a tree map sorted map interface. Okay, so let's go towards the topic. So basically, basically, tree map. It's a let's see what is a tree map. Let's suppose whenever we giving some input to the our tree map in jumbled manner, like I am giving the integers like 4, 5, 2, 1, 3. So it get that manner, but it does not follow that sequence. It gives us output in a proper sorted manner. That means it gets the value in jumbled manner and it gives us output like in sorted manner as a 1, 2, 3, 4. That means it gives in a sorted manner. And in another case, if we are giving some alphabets, like we are giving alphabet, suppose B, C, A, D. Also in that case, it give us output in a sorted manner as a B, C, D. But these are classes. But when we are creating our own class, as per our requirement, we are have to create our own class. Suppose I am creating a my class like a student class, or I am creating a class like a demo. So that time that our tree map does not understand the specific value regards that classes. So for that time, it's a problem to give us output in a sorted manner. That time we have to implement our own sorting implementation in this case. That time we have to introduce our own sorting implementation for that specific objects or classes. Okay. So after that we see what are the some uh, features, or what are the some advantage disadvantage of our uh, tree map. So tree map, it is a balanced tree. That means when we are giving some inputs to that map, it having a balanced manner. That means it put all those value as per their value. Suppose we are giving a one value, that is 10, then we are giving another value as 5. So that value is less than first value. That time it put in right side, or that if that value is bigger, then put in a left side. So that is the balanced manner. That means all both sides are properly balanced in this case. After that, next point is that our tree map does not allow a duplicate keys. That means we are seeing what are the keys and values in our previous video. So our map does not allow the duplicates. After that, next point is that our hash map, our tree map does allow our tree map allows only one null key. It does not allow more than one null keys. Okay, these are the some uh, features about the tree maps. So now let's we go towards actual internal implementation of our tree map. So as we discussed in our previous videos, like in our linked list video, there is a concept of node. So also that concepts are again comes here. We are know that the node are having consisting of key, values, and next variable. In this case also there is that node also consisting of key, value, and their different variable. But in that time we are considering that variable as a node left and node right. That means we are depending on sorting all those elements on the basis of left and right in this map. Okay, so we are creating nodes for that. At initial level, when we giving input to the tree map, we can write as a uh, map dot put. and we are giving our value or integer. So in this case we giving an integer as a 10. Suppose in the case if we are set key as a string, that means that time that string does not having some specific integer value, so there is some problem for comparing that value is bigger or smaller as compared to other value. That time for overcome this point, we are using we are using a hash code concept in this case. That means hash code are having its own library in Java. That time we are having for each object having its own specific hash code value. So that time we are converting that string into the hash code, and that hash code give us value in terms of integers. That time we are easily compare that value with another values. Okay, so comes to our point. uh, Suppose we are putting the first value as a 10, so we have to place that 10 on a root position. That means we again create one more variable as a node root and giving that null. That means that root at initial level, that root is null. When we putting first value, that time we have to check that our root is null or not. Suppose our root is null, that time we put that 10 value on the root. Okay, so our now our root is completely filled. After that, the next value we are putting giving, like suppose we giving that value as a 12, we can write as map dot put 12. After that, we are going to segregate that value in manner like that we are going to compare that value with the previous value. Our previous value is 10 and our current value is 12. So we can write a condition in our code like that. If our root sorry our value, if our value is greater than uh, previous value, that time we are getting some one more temper, we can find out that our previous value is greater than current value. That time we put that new value or new object in our right side of that our previous object. Or if that value is um, bigger smaller, that time we put our at our left side. So that is not any specific reason to put right or put small big value at right side and small value at left side. We can do it vice versa also, but our understanding we get considered as we are putting a bigger value at right side and smaller value at left side. Okay, so that time we are checking that conditions. When our, our first condition is that we are checking the first condition, if root is equal to null, that time if our root is empty, that time we directly put that object, that new values object in our root. If root is not empty, then we are going to check the comparison between that value is bigger or smaller than uh, old value. If we found that value is greater than previous value, that time we are put that value at the right side. Before that we check that right side is empty or not. If that right side is empty, we directly put that element on that right side. After that we get one more element like as map dot put 5. So that time we put the 5 element on our map. That time also at our first case we are going to check our root is null or not. So that time our root is not null. So because of that value is smaller than our root value, that's why our value goes toward the left side. That time we are going to check that left side is null or not. If that value is null, that time we directly put that 5 value at the left side. Okay, as per their segregation should be done. After that we are getting one more value. Suppose we write as a map dot put 1, getting a value of 1. So again in that case we check that condition, our root is equal to null or not. In that case our root is not null, then we are going towards that left side, and again we check that the second element is null or not. Again that is not null, so we are going to compare that 5 value with the new value, new object. That means the 5 is smaller than 1. Sorry, the 5 is 1 is smaller than 5. So that's why also it goes at the left side of 5. That time also we are going to check that scenario, if that position is empty or not. If that position is uh, if that position is no, not empty, we are going to check that next element is empty or not, or we are putting that element on that specific location. So after that overall segregation or overall alignment of that elements, if we see at the extreme left of our map, we got the minimum value. That's our one. And if we see at the extreme right of our map, that is the 12. That is the maximum value of our tree. So that's why when we are get output or when we are print that map, that time we get overall map in a segregated manner. That means it show us output like 1, 5, 10 and 12. That means it give us in a segregated manner because of that implementation of tree. So that is the easiest construction as compared to our array list and linked list or our linked map or linked hash map or our hash map. Our tree map is faster as compared both of those, both of that two maps. So that is the major advantage and that is the overall implementation of a tree map. Thank you.